have 5 students who had both level E and level M answered correctly, all questions answered correctly. So congratulations to all those 5 students. But Raghav was the fastest one on both levels. So that said, Raghav is the spotlight student of the week, of week number 12 for both levels. Congratulations, Raghav. This is the, I guess many times you have won this Spotlight Students Award. So apparently you are doing very well here. Okay, congratulations. Raghav, since you are the Spotlight student for both levels, I want you to pick a problem you want to talk about. Okay, which problem do you want to talk about?
For level E, I think I can talk about number 2.
So level E, number 2. Okay, how about level M?
I'll talk about number 1 because it was
so number 2 in level E and number 1 in level M. Okay. I have a few other students who answered all these questions correctly. So they are Pei Heng, Changxi Gao, Bella Sangavi, and Olivia Chen. Any of you are here? If you're here, you can unmute yourself, and I'd like you to pick a problem.
I am here.
Okay, Pei Heng, which one do you want to talk about?
I'll do M3.
M3, hold on, let me take a note, okay? So Raghav was E1 and M2.
It was right? E2 and M1.
Oh, E2, M1, sorry. And Pei Heng is M3, okay? And I have, who else? Bella, is Bella here? Bella Sangavi?
Yes, I'm here.
Okay, which one would you like to pick?
I will do M2, I guess.
M2, okay. And then I have Olivia Chen. Is Olivia here?
Yeah.
Okay, which one would you like to pick?
E1.
I'm sorry?
E1.
E1, okay. I have Chelsea. Chelsea here. Is Chelsea here?
Yes.
Okay, which one would you like to pick?
E4.
4, okay, good. So we'll start from E1. Okay, E1 is Olivia's.
Okay, so I found all the factors of 2020.
So you did a factorization for 2020? Is that what you did?
Mm-hmm.
Okay,
yeah.
So what did you find?
So I found that 2020 had 12 factors.
Okay.
Which were 1 in 2020.
1 in 2020.
And then 2 in 1010.
Okay.
4 and 505.
Okay.
5 and 404.
Okay.
10 and 202.
Okay.
And 20 and 101.
Mm-hmm.
So then I saw that since you need 5 different positive integers, then you need 5 different numbers that either add up to 1, 2, 4, 5, 10, or 20.
Okay. So you need 5 different numbers that add up to what?
To either 1, 2, 4, 5, 10, or 20.
Okay, to either 1, 2, 4, 5, 10, or 20. Okay, good. Because you want the greatest common factor, right? So, you could also have them add up to 2020 or 1010, but those leave the common factor too small, right? So you're looking for these numbers, okay?
But then there were 5 numbers that were able to add up to 20, so the greatest common factor would be 101.
Okay, so you find that they add up to 20, so the greatest common factor is 101. That's the answer. So why not 10? Many of you gave me answers of 202, and then I guess you find the 5 numbers add up to 10. So why not 10?
Because
Olivia?
5 numbers can't add up to 10.
So 5 different numbers, and they have to be non-zero, basically positive integers. 5 different positive integers, at least it will be 1, 2, 3, 4, 5, right? So they add up to 15. So that means these 5 different numbers at least will add up to 15. And among these 1, 2, 4, 5, 10, they are too small, so it has to be 20. Okay? Cool. Any questions or comments on this problem?
Is there like the prime factorizations in prime, the smallest multiple of the 2 primes, the least factor in the prime factors that was greater than 15.
Okay, so you basically Leo said he did a prime factorization, looking for factors greater than 15. And then the smallest one is 20, so 20 times 101. That's it. Okay.
Can I share mine?
Okay. So is that different?
Yes.
Okay.
Because we know that sum of 5 positive integers is 20.
Okay.
We can write them ax, bx, cx, dx, and ex.
Okay.
After I got this, I wrote a simplified. A plus B plus C plus D plus E times X equals 20.
Well, I think this is the same as what they had, right? So basically you factorize 20, and then you come up with A, B, C, D, E, add up to 20, right?
Uh-huh.
Yeah, I think that's the same. Okay.
Okay.
Good try. All right. Let's move on to E2. Raghav had this one?
Yes.
Okay, so this is a calendar problem. Okay, go ahead.
Okay, so first I know that in May there are 31 days.
Okay, 31 days in May. Very good.
And so then I found the closest multiple of 7 that is less than 31, which is 28.
28. Okay, that's the biggest. Well, also closest multiple of 7. That is, the multiple of 7 closest to 31. Okay.
Which means that the last week of May, which doesn't go past May 31st, will have 3 days.
Okay. So there will be 3 days left. This is 31 minus 28 is 3. Okay.
Which means that there are 3 days with 5 days in the month.
What do you mean 3 days in 5 days in a month? What do you mean?
Like in each week there is going to be one of each day. So like in the last week there will be 1 extra of 3 of those days.
Yeah. So there will be 3 extra weekdays.
Yeah.
Okay. Then?
So then I just saw that the only day where you cannot where there will be 4 Saturdays and 4 Wednesdays is when it starts on Sunday.
So it starts on Sunday, and then at the end you end with what? End with
Tuesday.
Saturday. So that's the 4 weeks. So these are the 4 weeks. All right. So start from Sunday, and then end with Saturday. So that's 4 weeks, and then you have 3 extra days. That will be Sunday, Monday, and Tuesday. These are the 3 extra days, right?
Yeah. So which means
so
like,
this will be 31st. This will be 30th. This will be, yeah. That's it, right?
Yeah. So Monday the 30th would be the last day.
Very good. Very good. Okay. Any other questions or comments on this one?
I have a different solution.
Okay, Leo has a different solution. Go ahead.
So I saw that in between Wednesday and Saturday, there will be 2 days.
So between Wednesday and Saturday, so there will be Wednesday, Thursday, Friday, and Saturday. So there are 2 days in between.
And in between Saturday and Wednesday, there are 3.
So from Saturday to Wednesday, there was Sunday, Monday, Tuesday. So Sunday, Monday, Tuesday, there are 3 days. Okay.
Yeah.
So
then I saw that from a first Wednesday to a fourth Saturday, there would be 28. There would be 28 minus 4 equals 24 days.
Okay, so if in a month you first observe Wednesday before Saturday, right? So that will be from Wednesday through Saturday, and then Wednesday, and then Saturday, and then Wednesday, and then Saturday, Wednesday, and 1, 2, 3, 4, and then Saturday. So this is how many days?
24.
So this will be 4 times 28 minus 20 minus 4 is 24. No, 4 times 7. Sorry, 4 times 7 minus 4 is 24 days. Okay.
So, what?
Is this 24 days? Let me see. Saturday, and then you are missing Sunday, Monday, Tuesday.
Wednesday.
And why another Wednesday? So it's
no,
minus
actually
3, right?
It will be 20.
25, right?
Yeah.
25. Okay.
So then I saw that would be so then I saw in the beginning you could fit Saturday, you could fit 3. You could fit
Sunday, Monday, Tuesday, you can fit at the beginning, 3 days.
Since it would be in between Saturday and Wednesday.
Okay.
And at the end you could also fit in 3.
Another 3 days, Sunday, Monday, and Tuesday, another 3 days. So 25 plus 6, that's 31. So that's how it works, right?
Yeah.
So then the last Monday will be 30s, right?
Yeah.
Okay, good. Okay, I think this is good for this problem. Any other questions on this one? No, let's move on. Oh, nobody wanted to talk about E3. Let's see E3. If nobody wants to talk about it, then I'll talk about it. Okay, this is actually a tricky problem because I typed the problem wrong. I meant to ask you for a different thing. But the way this is articulated is there are 2 answers actually. By the way, any one of you for this problem, any one of you find 2 answers?
Kyle?
Okay, Kyle, did you find 2 answers?
Yeah, can I tell the
Sure.
answer?
Go ahead.
Well, maybe not.
Well, I'm working on it.
You don't want to talk about it? Okay. Well, most of you gave me an answer of 16. Okay. Most of you gave me an answer of 16 problems. And this definitely works. Okay. So look, so there's an answer sheet. He spent 2 minutes to complete each problem. If he spent 2 minutes to complete each problem, then there are 6 problems left. That means you work on 10 problems.
Well, I have a solution.
In 20 minutes, right? And then if he spends 1 minute on each problem, he will have 4 minutes left. So if he spends 1 minute on each problem, then he will spend 16 minutes, okay? And if the total exam is 20 minutes, there's 4 minutes left, okay? So 16 works, okay, 16 works. Wait, there's another solution. Let's take a look, right?
Mm-hmm.
Oh, you find another solution?
No, I found the way to solve
it. Did you find a different solution than 16?
No.
Okay, then, all right. So let's see. I can tell you the other solution is 15. Let's see if it works, okay? 15 problems. If there's 15 problems, okay, and Leo spends 2 minutes to complete each problem and having 6 problems left, that means Leo worked on 9 problems, okay, 9 problems. That means Leo spent 18 minutes, okay? This doesn't mean that the exam is 18 minutes, okay? The exam could be 19 minutes. As long as the exam is less than 20 minutes, Leo would have 6 problems left, okay? And then if you have, if Leo spend 1 minute on each problem, 1 minute per problem, then that means he spent in total 15 minutes. Okay, 15 minutes. And they said there's 4 minutes left. 4 minutes left. That means the total exam is 19 minutes. Okay, it worked. Okay, 19 minutes. If the exam is 19 minutes, okay, the exam is 19 minutes, and there are totally 15 problems, that works too. So that's the other solution. Okay, so for this problem, no matter you answer 15 or 16, I made it right. So I mean, I consider it's a correct answer. But the original, my original problem was what's the least number of problems are there in the exam? So if I were asking the least number of problems, you would have to answer 15. Okay, so let me tell you a general way of solving this. Okay. You have a solution?
Yeah.
Okay, go ahead.
So I made the amount of problems X.
Okay, X problems.
So if there were two, if he spent 2 minutes on the test, then
2 minutes per problem.
2 minutes per problem.
Okay.
Then he would have 6 problems that he didn't do.
Okay.
So I made the equation 2x minus 12.
So that's 2 minutes times x minus 6, right? So that's 2x minus 12, okay?
And then I made the x, the one where he spends 1 minute on each test. And he would have an extra 4 minutes, x plus 4.
X plus 4, okay.
So I made them equal.
Equal.
So I subtracted x from both sides.
Okay,
and
then you solve
12.
it. X equals 16, right?
Yeah.
But why didn't you get 15?
Because he didn't say at least.
Okay, at least, right? No, not at least. There's no at least. I said if he spent 2 minutes to complete.
No, you didn't say
Oh,
least.
I'm saying, well, if you solve this problem, you should have 2 answers. The correct answer should be 15 or 16. That's the ultimate correct answer, okay? So let me tell you how to get to 2 numbers, okay? So first of all, you have 6 problems left. So if you consider the exam is t minutes, okay, t minutes, that means 2x minus 6, okay, 2x minus 6, this is less than or equal to t, right? Because this is t minutes, okay, exam was t minutes. That means within the exam, you finish x minus 6 problems, okay, within the time limit, right? On the other hand, is that Leo has 6 problems left. That means if Leo work on another problem, Leo will go beyond the limit. So that means 2 times x minus 5. T is less than 2 times x minus 5. Okay? The exam time is less than 2 times x minus 5. In other words, if Leo finished 1 more extra problem, he would go beyond the limit. Okay? So that said, another one was x. 1 times x plus 4 is t. Okay? Now let's solve this inequality. Okay? So here is x plus 4 is t, so I just substitute t by x plus 4. Then I'm getting 2x minus 12 less than or equal to x plus 4 and less than 2x minus 10. Okay, we can solve left side first. This one we solve is subtract x from both sides and add 12. That will be x less than or equal to 16. Okay, on the right we have subtract x from both sides and add 10 from both sides. So this is greater than 14. That means x equals 15 or 16. Okay, got it? Any questions about this one? All right, if no, let's move on to E4. No wonder nobody wanted to talk about E3. Okay, anyway, E4 is Chauncey's. Chauncey, go ahead. This is a logic problem. Chauncey?
Yeah.
All right, go ahead.
So I decided to make a graph.
Okay, make a graph. How did it work?
So it have the 4 kids' names on the top, which
Okay.
I just put the first letter of their name.
James, Russell, Stephen, and Kevin.
And then on the left side, I put the Dr. White and Dr. Green, which I just put W and G.
This is how it works? You mean a table? Like, okay.
So in this case, I decided to say, since Steven's age is half of one of Dr. White's children's age, in this case, I would say that he wouldn't be part of Dr. White's family.
Stephen's age is half of one of Dr. White's children's age. Well, not necessarily. Well, it could be, Stephen could be, half of the age of his brother.
Yeah, but like in this case.
In what case?
Well, like, let's just say that he isn't part of Dr. White's family.
He is? Or is not?
Let's just say that he isn't.
Isn't. Okay, so let's say if Stefan is not part of White's family, okay?
And then let's also say that, if Kevin wasn't part of Dr. Green's family.
What's that? Kevin?
Yeah, like, let's say that Kevin isn't part of Dr. Green's family.
If Kevin is not part of Green's family, so that will be Kevin is not Green, then Kevin must be White, okay?
So you don't have to worry about James since he's the oldest. So then, for now, so if James isn't part of Dr. Green's family.
So you want James to be part of Dr. Green?
No, if he wasn't part of Dr. Green.
Okay, that will be part of White.
And if Russell isn't part of Dr. Green. No, I mean Dr. White.
Russell is Dr. White or Dr. Green?
Yeah, Dr. Green, that's right.
Okay.
So I decided to start with Stephen. So
sorry, I think you're trying to, well, you made a lot of guesses, right? So you guessed all of these. But I need support. I mean, why do you guess this way? I need reasons. I mean, Stefan could be part of White, and the Russell could be White. So why did you guess this way? Any reasoning? You want to think about it?
I have a way of solving it.
Okay, go ahead, Raga.
Okay, so if James is the oldest among the four, and Russell is 4 years older than his brother, that means James and Russell cannot be brothers?
Ah, so based on the first two conditions, that means James and Russell cannot be brothers, right? James is the oldest, and Russell is 4 years older than his brother. And remember, these two families met 5 years ago when each family only had one child. Okay, that means James and Russell must be the older child of each family. Okay, that's good. So that's a good reason.
So what I thought was
hold on, there's some background noise. Everyone else, please mute yourself. Okay, go ahead, Raga.
So what I thought was both Stephen and Kevin have to be less than 5 years old.
Okay, so that says Stephen is less than 5 years old and Kevin is less than 5 years old. Okay.
So, and since they're both a younger child, that means Kevin is 2 years older than Steven.
Since they are both younger child, so means Kevin is the older one, is older. Kevin is older than Steven. So that means Kevin is Steven plus 2, right?
Mm-hmm.
And also it said Kevin is older than Dr. Green's younger child. That's why Steven is Dr. Green's, right? And Kevin is Dr. White's. Okay?
Yep.
Good?
And so I created an equation.
Mm-hmm.
It's like I made s plus 2
Mm-hmm.
is equal to 2s.
S plus 2 is equal to 2s.
Yeah, because of the third condition.
It said the third condition said Stephen's age is half of one of Dr. White's children's age. So Stephen is apparently the youngest one among all, right? So Stephen's age is half of one of Dr. White's age. So why did you do Stephen is half of Kevin's? Why not Stephen is half of either James or Russell?
Because like they're older. So if like it's half of James, it might be greater than Kevin, and because they're all different. So I thought that I made the equation 2s equals s plus 2 and got 2.
Can I give it a try here?
Wait,
So
I know.
Okay, go ahead, Leo.
So since they both have to be less than 5,
Okay.
then that means that at most, Stephen is 2.
Okay, so Stephen, since both Kevin and Stephen will be less than 5, and Kevin is 2 years older than Stephen, so that means, well, Kevin at most will be 4, right? And then Stephen at most will be 2. So Stephen, the oldest Stephen, the oldest age Stephen can be will be 2, right?
But then neither James or Russell can be 4 years old.
Okay, because James and Russell are both greater than 5.
So Kevin is twice as much as Stephen.
That's why Kevin is twice as much as Stephen. Very good.
So then
Okay.
Stephen is 2.
So Stephen is 2, Kevin is 4. Okay? Keep going,
I have
Raga.
a question.
Okay, David?
So why cannot Kevin be 5 years old and Stephen be 3?
Well, the way it's said is they met each other 5 years ago when they had only one child, and now they have 2 children under 10 years old. Under 10 years old means the oldest one can be, the oldest one will be 9. Okay, so that means 5 years ago they don't have any kids. I mean, that's why nowadays they don't have 5-year-old kids. And even if you have 5 and even if you make Kevin 5 and Stephen 3, you eventually will find contradict somewhere. So okay.
And also it has to be even as well.
Say what?
The age for Kevin has to be even.
Yeah, I think David's comment was if Kevin was 5 years old and Stephen was 3, then one of James James is the oldest, and then Russell will be 6. Okay, Russell will be 6 years old. So Russell will be 6 years. I mean, will be twice as Stephen. So, but then you don't. You don't have anyone. Russell is not 4 years older than his brother anymore. Okay, so let's say Russell is part of White's family. It cannot be 4 years older than the brother. Okay, got it, David? So even if you do 5 and 3, it will contradict later on. Okay.
Okay. I was just wondering.
Yeah. Yeah. Raghav, go ahead. Keep going. So now you have Kevin as 4, Stephen as 2.
So that means 2 is the answer.
So that means what?
2 is the answer because they're asking for how old Stephen is.
Oh yeah. How old is? Yeah, very good. So 2 is the answer. Well, you don't have to keep going for the other ages.
And it will work no matter what because Russell can be both 6 and 8 with James still being the oldest.
Yeah. Okay. Well, I think we're done with the elementary school, elementary level problems. But there was one last question I want to ask you. Do you know how I name these people? There's James, Russell, Stephen, and Kevin. How did I name them? Why did I make these names?
I think it's your friend's children.
People from your class, from
Nope.
your high school class.
Nope.
People from your college class.
Nope.
Well, wait, I know someone named Kevin. He's like in high school or something.
Nope. Think about it. How did I find out these names?
Oh, you randomized them.
Nope.
But I feel like
People from students.
is it just some?
NBA.
They're the most popular names.
Russell Westbrook.
Okay, who said NBA?
William.
William, okay, go ahead. Tell me the names. What are their names?
LeBron James, Russell Westbrook, Stephen
Oh,
Curry.
come on. LeBron James. James
Harden.
will be the last name. Okay.
James Harden.
Okay, James Harden.
Russell
What's
Westbrook,
next?
Stephen
Russell
Curry,
Westbrook?
and Kevin Durant.
Okay, Steph Curry and Kevin Durant. Those are the most recent 4 MVPs. Okay. If you look for the MVPs of the recent years, they are the 4 MVPs. Okay.
Wait, is this actually like, is this actually how much older they are?
Of course
And
not.
each other.
Of course
But who
not.
do you think
So
should win the
Stephen Curry's
MVP
2 years
for
old.
this season?
No,
I
don't
think
mean like
Giannis should win.
This is not.
Do you assume? And do
What
you
about
assume,
Kobe Bryant?
do you guys
Kobe
assume
Bryant's
Kevin is
retired,
Russell-
dude.
And do you guys
Yeah.
assume that Kevin is
He's
Stephen's
already
brother?
dead.
Say what?
Kobe Bryant is also rest
Okay.
in peace.
Okay. What did Connor say? Connor, what did you say?
I was joking. I was saying that they said they were asking if people are 4 years older than if those were the real ages. I was saying, do you think that maybe Russell Westbrook was Kevin Durant's brother?
Okay. Okay. Well, they are like brothers. When Russell Westbrook and James Harden and Kevin Durant, when they were in the same team, they were like 3 brothers. Okay. All right. So that's done. We're just done for the elementary school problems. Let's move on to middle school. Okay. Yeah. Now I know all these players, so it's so easy to make names for these problems, right? So I don't have to use Leo, Isaac, and Kyle, and your names, right? Okay, M1. Who got M1? Right after M1. Okay. Go ahead, Raghav.
Okay. So like, if you see it, they don't give you like the first or second term for you to start it off.
Okay.
So like, I wrote the first term as X,
Mhm.
and the second term is Y.
Okay.
And so like, I know a trick to solving these problems, and
Okay.
do I prove it or can I just tell the trick?
I think you better prove it. If the proof is not too long.
Okay, yeah, it's not that long. So that means we know that the third term is X plus Y.
Okay.
Fourth term is X plus 2Y.
Plus 2y.
And like, you just keep on writing it out until the 10th term.
Okay. So should I write the other ones?
Sure.
Okay. 2x plus 3y. So there's a 5. I'll just keep writing. So 3x plus 5y, and then 5x plus 8y, and then 8x plus 13y, and 13x plus 21y. The last one is 21x plus 34y. Okay.
And if you add them all up, you get 55x plus 88y.
So sum is 55x plus 88y.
And you can see that that is 11 times the 7th term.
Okay, so this is 11 times the 7th term. Okay, excellent.
And if you know that the sum is 231, that means the 7th term is 21.
Is 231 divided by 11 is 21. Very good. So this
And then
is,
you just solve the system of equations.
okay, and I also know the 5th term is 13. So this is 13. That means 2x plus 3y is 13, and 5x plus 8y is 21. And the question is, what is the third term? The third one is x plus y, okay? basically you can solve them and get x plus y. Okay.
Okay, yeah. And then you can see that x would be 41 and y is negative 23. So if you add them together, you get 18.
X will be 41 and y is negative 23. So then x plus y is 18. So 18 is the answer. Okay? Very
The thing
good.
that makes you unsure is the negative 23.
Huh?
The thing that made me unsure was the negative.
Yeah, so I didn't say, I think some of you were trying to, looking at this, you thought this is a Fibonacci sequence. You started with 1, 1, 2, and 3, or 1, 2, 3, 5, something. And then finally you got 13, but 13 is not the 5th term. 13 is probably 6th or 7th term.
It is the
Right?
6th.
6th one? Right, so you might be confused, right? Well, this meant to have you confused.
Or you can actually notice the Fibonacci and the x plus y, x plus 2y, 2, 3, 5, 8. The y is the x also.
Okay, so those are the coefficients of x and y's. Okay. All right, very good. So basically, Raga figure out this trick, right? So this is the sum is 11 times the 7th term. Okay. That made it much easier. Okay.
But is that always true?
Yeah, it's always true for every number.
Right. Any other questions? Okay. Yeah, if you look at this is 55x times 88y. You can write it as 11 times 5x plus 8y. Okay. 5x plus 8y is the 7th term. So no matter what.
That only works for 10 terms.
Yeah. So for the 10 terms, yeah. Okay. Any other questions? No. Let me move on to Bella. Bella, you have M2. Okay, Bella, go ahead.
Okay, so we know that Leo draws a convex pentagon, and then he draws a star shape essentially inside of it.
Somehow I can't copy. Okay, oops. I'm trying to copy the problem here. Okay, now let me do it. Paste. Okay, so Leo draws a convex pentagon. A convex pentagon. And then connect all the diagonals. So this is what he did, connect all the diagonals. All right, go ahead, Bella.
Okay, so I saw that there was another pentagon shape in the middle.
Okay, so should I number them? A, B, C, D, E, F, G, H, I, J. Okay, so there's another pentagon in the middle, okay?
So I labeled that pentagon P.
P, okay.
And then I labeled all the other triangles around it, like AEF1 and AFG2, and then so on.
Oh, okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you have 10 of those.
Yeah. So then I went to each singular triangle, and then I went to every. So I'd do 1, and then 1 and 2 would make a bigger triangle, and I was trying to.
So I like it. Okay. So what Bella did was Bella start with the smallest triangles, the singular triangles. There's only one triangle there, only one triangle here. So these are singular ones. So we said there's singular triangles, one triangles. There are 10 of them. 10 of them, right? 10 of them. And then she moved to 2 triangles. So like AEG, it's made by 2 triangles, right? AFB is made by 2 triangles, right? So how many of those did you find?
So I found.
I have a question.
Yeah, hold on. Let her finish.
I found 9 or 10. Sorry.
10 of them. Okay, so AEG, AFB, and the BAH, BGC. So basically, for every vertex, you can find 2 of these triangles with two little triangles inside, right? So you have another 10.
And then I went to 3 singular triangles.
3 of them, like AEB, right? So this is 3, AEB, and BAC. Again, for every vertex, how many do you find?
I found only 5 this time.
5. So 1 for each vertex, right?
Mm-hmm.
Okay, keep going.
So then I started to realize that you could also use the pentagon in the middle, and you could make triangles with that too.
All right, so there will be some triangles plus the pentagon. Okay, tell me what are those?
So there was one like 2, 6, and P made a triangle.
Okay, so AJC, right?
Mm-hmm.
AJC is a triangle. So that's two little triangle plus a little pentagon in the middle. Okay, how many of these do you have?
I found 9.
9 of
No, I found 10.
these?
Sorry, 10.
10 of these? Okay,
Mm-hmm.
so that's like AJC, there's 1. Okay,
No, how could there 5?
yeah, how did you find 10? So AJC is 1 and AHD is 1. But when you move to C, you will have CJA, which is the same as AJC, and then CEG. So
There's one for each vertex on pentagon P.
yeah, so for pentagon P, you connect pentagon P with A, so that would be AJC, AHD. There are 2, but then you count them twice. Right? So for every time you go back to another vertex, you count them twice. So that will be 5 instead of 10.
Okay, so then I started adding on more triangles. So there's another triangle like 2, 3, 4, P and 8.
2, 3, 4, P8. Okay, so that will be 1, 2, 3, 4. 4 triangles plus the pentagon. 4 triangles plus the pentagon in the middle. So that will be another 5, right?
Yeah.
So like ABD. So if you look at these are all using vertices of this original pentagon. So you basically there are 5 vertices, and you pick for every side you can pick ABD. With the non-adjacent vertex ABD, and BCE, DCA, DEB, and AEC. So there are another 5. So in total, there are how many?
There's 35 triangles.
35. That's the answer. Good. All right.
I have a question.
Okay.
For the triples triangles, I can only find 8 instead of 10.
For the triples, for each vertex there is 1. So see ABE, there is 1, right?
No, like the 2 triangles plus the pentagon. I can only find 3 of those.
2 triangle plus pentagon. Okay. So take a look. Okay. We all go with with the pentagon. We all go with the one on the left. So AHD, there's 1, right? AHD. Let me write it down. AHD. Okay. And then when you go to B, BIE, BIE. Okay. When you go to C, CJA, CJA, D, DH, CJA, D, what's this letter? F, DFB, DFB. And then when you go to E, EGC, EGC. These are the 5. Got it?
Mm-hmm.
All right. So these are the 5 here. Okay. Any questions? Okay. If no question, let's move on to problem M3. Pei Heng, your turn.
Okay. For
I'm trying to copy this.
okay.
Copy. Paste. Okay, go ahead.
So for entry, you draw the 3 circles by each other.
Okay,
With
3
the
circles. Like this?
Wait, I think my thing broke. Yes, like that.
So I just mark ABC as well?
Mm-hmm. Then I drew lines connecting all the tangents together
So
in a
make
triangle.
Make a triangle ABC, okay?
Uh-huh. Then I think no. Actually no. Draw the center. The center of
Center of the
circles
circle, okay?
and name it O, then draw it together.
You connect the centers together?
Uh-huh.
Okay.
Because all of these are the radius. They are 2 radius. The side lengths are 2 radius.
Okay,
So
all these
so it's an equilateral triangle.
okay, so this O1, O2, O3, this is the equilateral triangle, okay?
Because it's an equilateral triangle, all the degrees are 60.
Okay, all
60
60
degrees.
degrees.
Then we can find that one triangle, the side lengths are, because it's also an equilateral triangle,
So
because
basically, C is also equilateral and the side length is R. Okay, good.
after you figure that out, you can know the middle is also an equilateral triangle of R.
Yep. So ABC is a equilateral triangle with side length R. Okay.
Then you can do a formula to figure out the area of a equilateral triangle.
Okay. So what is that?
3, the square root of 3 divided by 4 times pi, times by radius squared.
R squared, right?
Yeah.
Okay. And then
But
this.
then you have to divide it by the area of one of the circles.
All right. So circle is pi R squared. Pi R squared. Okay. So
After you do this, you can cross out the R squared and get the square root of 3 divided by 4 pi.
Okay, square root of 3 divided by 4 pi. That's the answer.
But you can't write that, so
yeah,
you had
it will be rounded to 0.14, I think, or 0.138 or something, 3738.
You had us rounded to 0.14.
Yeah. Okay. Good.
You can also prove the square of 3/4 times R squared by the Pythagorean theorem.
Oh yeah, yeah. So this is you can calculate it. Okay. All right.
I have a question. So if you say in the comments that the answer for M3 is √3/4 pi, will you get it correct?
Yes. Yes.